Well, hello. In the race to the end, trying to keep our time. It's very impressive following the people who we are following this morning. Several of them were people who would you put in the category of doers, people who say, screw waiting around for a plan, let's just go ahead and act. And the world is partly made by such people. And then we just saw a couple of my colleagues in the Envisioner department, and we're very grateful to be part of a civilization that doesn't burn us at the stake anymore, but we instead pay us and listen to us blather. And our role is to be interesting, not necessarily to be right. Sometimes there's a correlation, and that makes us more interesting. But what we're talking about here is a bunch of people who are paid every day to be right. They're paid to keep their companies going, to bet properly, allocate resources properly, to be agile, to control teams, to manage and stimulate teams of creative people. And yet we've challenged them to be envisioneers today, the last 48 hours, less than 48 hours. And their job here was to, number one, to have fun at FiRe. That was the number one thing. You guys paid your nickel. But the other thing is to be interesting. These guys are going to judge whether or not you're right. So I'd like to announce a small change in our schedule here. You might have noticed a slight drop in charisma and a slight increase in shininess here on stage. Wonderful Sophie had to go. She was a hugely important contributor, I'm told, because I kept my distance, as promised. And instead we have Robert Hadley, who was by acclaim, and I've heard that a bunch of you were great contributors in the breakout sessions. And I hope some names will be mentioned. But Robert Hadley is a real estate impresario in Honolulu and Seattle, and apparently a really, really good guy with numbers and practical solutions to problems. So welcome on Robert, welcome on stage. Almost makes up for the lack of Sophie. By the way, you know, every year I'm watching you guys, and I take the CD away because we're keeping our eyes open for potential future team members if the show ever gets resurrected. If we ever find a really, really good sponsor who gets the show and supports it. So you're all possible recruits. So did you have fun?
Yeah, absolutely.
Oh, terrific. Well, in any event, did you come away with invigorated imaginations that you can then take back to your day jobs?
Certainly,
Definitely.
Great. Well, in less than 48 hours, you have been challenged, and I'll see if I can act like Commissioner von Essen, you know, or the four-star general, and say, oh, now I can say the word, gentlemen. Gentlemen, show us what you got.
Very good. If we can go to the presentation, please.
Ty's got the clicker. Presentation.
That's great.
So we thought we'd frame the problem in a definition of how to survive in the desert. Very appropriate considering where we're at and the challenge everyone faces. And I'll apologize if we go a little bit fast, but there's a lot of discussion to be had, and I would like to cover the topics fairly quickly because the interesting part is in the details in the discussion. So we'll move quickly through this and cover some of the base background. So the first thing we observed when we looked at the problem was trying to understand the scope of the problem. It was a huge challenge because there's hundreds of pages of things to read. And fortunately, thanks to Bill Rose of the San Diego Water Authority, we really capitalized his time, and for hours upon end, we were asking him numerous questions about the details of water management and water movement in San Diego. And thank you very much for that. That was a big challenge. But fundamentally, we know a few things. One, San Diego's running out of water. That's no surprise. You take a look at the picture of Lake Mead, and you can clearly see the water levels dropping at an alarming rate. And to some extent, some of the details, the intakes for the hydro plant at Hoover Dam are within 100 feet of the water level. And when you think of a dam being more in a V-shaped type arena, you know that the first 100 feet takes a lot longer than the last 100 feet. And so there's a real challenge to be had here. The other challenge is growth is expected to grow by maybe 40% in the state of California. So we have an increased demand happening. At the same time, the rates are going to increase probably around in the order of maybe 340% over the next few years. Exactly, it depends upon demand and the results of our outcome here. We're very optimistic. So the demand data, basically there's about 700,000 acre-feet of water that was being consumed by the city of San Diego County. And that has been reduced to about 600,000, maybe 650,000 acre-feet of water in recent years due to conservation. So some of the efforts have already taken place, and there's a good trend in that. 50% is agricultural, about 50% of consumers residential. Interesting, facts are about 175 gallons per person in the San Diego County area are consumed every day. Ideally, if you're absolute fastidious about water, that would be down to about 50 gallons for that. And we look at things around policy and regulations. Basically, there's about 23 agencies, 17 cities involved. So this is a delicate piece of artwork. So you have a lot of science, but you also have a lot of art in how you manage this and how you provide communications and inform people across the arenas. The rates are highly variable. They're inconsistent between the retail consumers across the state, so that creates a challenge. And in fact, in some areas, the retail rates are actually flat. So whether you're using 50 gallons a day or we're using 300 gallons a day, you basically pay the same rate. So there's some opportunities here for scaling and understanding how to incent the correct behavior. Other data points, 70% of California's stream runoff is north of Sacramento, but 80% of the usage is actually in Southern California. Movement of water is very expensive with energy as well as resources, and that becomes a big factor in how we think about solving this type of problem. And we also have other things when we talk about gray water. There's a Department of Health regulations regarding that, and so there's policy issues to be considered with not only engineering aspects of it. When we look at who owns the water, the energy and power are just basically linked as a problem statement, because if you have to move the water around, it takes energy. If you want to create water, it takes energy. So you can't really deal with one without having some acknowledgement of the other. External sources to San Diego County, about 90% are coming from the Colorado River and the Metropolitan Water District. Local water is about 10%. There's a future desal plant that's being developed that will provide about 8% of the water demand. But as we'll note in the presentation, desal water is quite expensive. As we note, basically, I'm going to stand up here in just a moment because I can quite see the slide. Basically, on the conclusions, the current price of water that people are realizing does not reflect the true cost. And because of that, it's not really driving the behaviors that we want to see happen here. We're looking at multiple classes of water, whether it be potable water, whether you have gray water, whether you have black water, reclaimed water. There's some great opportunities to be able to use what they call purple pipes in the county, using reclaimed water to provide things such as watering the lawns and providing other reclaimed water options. Conservation potential reductions, commercial landscaping, maybe we can reduce that by about 50%. We looked at household consumer, reduced that by 66%, industrial cooling by about 40%. So there's some opportunities here to really save some serious volumes of water. But a couple of things about increasing the supply. Moving the water is expensive. We need to be able to focus on making more water locally if we're going to increase the supply, and look at rainwater capture in the individual homes. Recommendation on the supply side, desalinization cost about $1,700 an acre foot. So that's about $500 an acre foot are current costs. So this is a serious increase in costs over the next few years. If they have to use desalinization at any scale, this water is going to get very, very expensive. One of the options we looked at is reducing loss. This is an interesting thing to note as we started to understand the water movement in the area. There are a number of pipelines in the county, which make good sense. But there's also these canals. There's the All-American and Coachella canals. Together, they're about 200 miles long, about 100 feet wide. And these are aqueducts running basically through and they're open aqueducts, running through the middle of the desert in a very low humidity environment. And on the order of maybe 10% of loss is due to evaporation through these open canals. So there's another option there. When you think of 3.1 or 4.4 million acre-feet of water moving through these canals every year, there's a lot of opportunity here. And that's an area that needs further study as far as evaporation goes. On the demand side, to install residential landscaping in yards. One of the things that Bill was mentioning was that when you look around the San Diego area, you see all these beautiful yards with flowers and these beautiful decorations, and it's just lovely, even out in the yard of the Dell here. The challenge is that those plants require a lot of water, a lot of maintenance. And there are equally brilliant and interesting plants that can be used using native plants that are low water requirements that flower and bloom and have the same opportunities, but do not have that water usage. So we're looking at ways to be able to do that. One possibility is to take the street of dreams and actually change what the social norms are. Some of the discussion that the team had at length was about how do we change what is the social norm? And by setting standards of examples, especially throughout the neighborhoods and in different areas of the county, that this becomes a social norm of what a great yard looks like and how you can be responsible to the neighborhood. We also know that agriculture, about 70% of California water is used by agriculture. Not so much in San Diego County specifically, but when you look at the overall water environment in the state of California, we have to look a little bit broader than just San Diego County. There's some great opportunities with using AcceleGrow incentives. One of the things we note in San Diego County, the largest user for San Diego County for water is the city of San Diego. 19% of that water is for parks, and that's typically for watering lawns. So we have some great opportunities using technology from SNS members and that area to be able to mandate that for public park and maybe reduce the water usage for the parks by 50%. And it's just some smart technologies that we can use to do that. We can also reduce inefficiencies in processing. In discussion with another SNS member, Alan Smith from Vesta, was that found out that they're washing fruits and vegetables basically 3 times in order to get the bacterial count down. Yet if you use the hydrochloric acid, a very low concentration that was approved by the Department of Health and EPA, you could reduce that water wastage by basically 2/3. Again, very simple techniques to allow these things to go through. Also using hydroponics or drip to reduce the agricultural use for production of food. We also want to empower the end user customers so that if they're making a change, they know what type of change they're making, they know how much improvement's going on. And so we want to be able to empower the end user customers via a social networking type interface so that when you log on to your water or you log on to your systems, you have the opportunity to take a look at what your water usage is on a daily basis so that when you take a shorter shower, when you use less water for irrigation, you change your landscaping to low water requirements, the user can actually look and compare the historical data. This is what you used last year, here's what you used this year, and here's the change from day to day. So that there's direct feedback provided to the users and encouraging them. But not only that, but showing what the neighborhood average usage is, or in the county, how you stack up with respect to the county, because information is power, and it also, when you compare it with others, how you rate, it really makes you feel good, and it also is a great incentive for making change. So that would include smart meters to enable that, including temperature and humidity that allows some predictive capabilities on how much water is actually used by yards and what have you. Smart home valves, this is a great idea. This is from Tom from Adobe, to sense gray versus black water. So one of the options is when you have a drain in the house, for example, that goes out into the sewer system. One of the things it could do is sense gray and black water, or even in the house having 2 piping systems where you have a gray water system, and this is allowed, according to Bill, this is allowed that you can have gray water systems that come off everything except the toilet and the kitchen sink. So your bathtubs and the other sinks in the house, for example, would drain out into a gray water area. And to make sure that water was actually truly gray, you can put one of these intelligent valves on there to sense if you have black water and then route it down to the sewer system. But this gray water, this would allow us to have a greater confidence in the gray water, particularly with like bacteriological content, to be able to water yards and do other things. Right now what you have to do is you have to water via subterranean. And perhaps if we got smart about how we manage gray water, we could actually use other techniques that were perhaps less expensive, but certainly an option for us. Xeriscape yards, we talked about that. One of the other areas is to amortize the capital costs for these type of improvements via water bills. We want to provide the right level of incentives. So one discussion was also, as the water rates are tracking to increase, you basically have 2 rates of increase. You have an increase that is for those who are not really following the incentive program, that they would have a higher rate of increase to get to that $1,700 per acre foot water bill. And if they started to incent themselves to using these conservation techniques, that they would actually track to the slower schedule for a very conserving type home, so that we actually incent people to have the correct steps. And obviously we need to make regulatory demands and things of that order that reflect being smart about how we use water. So some ideas and technical ideas came out of the Xerox Park filter is a great solution to be able to filter out particulate matter. This could even be used in a washer. You think when you use a dryer at home, you have the filter that takes the lint out. When you think about having a washer that actually was trapping particulate nature, and so that the water that was putting into the system had been reduced in particulate nature so that you have a more free-flowing system, and you can also take the filter out and then dump it into your compost or what have you to be able to use very effective use of that. But also living machines. These are basically water treatment systems that are very natural in design. They don't smell, they're not offensive, but it's a very, very efficient way to be able to reclaim water. And some of these systems can actually be integrated in building structures so that these buildings themselves are designed with the water remediation systems built into the building and providing water for the flora and fauna in the building, as well as at least having reclaimed, if not pure water, coming out of the building. Some really interesting ideas with technologies. On the creative ideas side, we talked about direct solar. There's an option to be able to use direct solar energy for providing energy for desalination, what have you. But some more interesting ideas also came out. Canal, remember the 200-mile canals, the All-American and the Coachella canals? Covering them with like a rubberized material to reduce that evaporation, so there is no evaporation because it's now a closed system. But on top of that, putting on solar panels. These solar panels will not only power the pumping systems to be able to move the water through the district, but also provide extra power for San Diego County and the city of San Diego. You already have the right-of-way, you're going basically through the middle of the desert, and then you can enhance that by, again, another SNS technology with Tigo Energy to be able to have very intelligent solar panels, so you're actually optimizing the power that you're getting from these panels. Another area we'll talk about, augmented ocean thermal energy, salt water for industrial and downtown core and fog harvesting. Drilling into that, we take a look at the heat flow map of the United States and basically where the heat concentration on the Earth and geothermal capabilities are. You look closer into San Diego County, and you notice the two ovals there. The first oval on the right, you'll see, is the geothermal aspect for San Diego County. The oval on the left here in the water map is actually showing the temperature gradient in the surface temperature of water. One of the big challenges we had was we have all this solar energy and we have this salt water, what can we do with it? Well, if we can create a temperature gradient between these two, we have the ability to either, one, use use ocean thermal energy conversion to either provide a power plant. There have been test stations built off Hawaii and these other types of areas where you have these geothermal gradients. But you can use geothermal to be able to create an increased temperature gradient from taking very, very cold salt water from the bottom of the ocean, pumping that water up, and then you have a temperature gradient created by geothermal water coming off of the coastline, and now you have the ability to make energy. Not only that, but you also have the opportunity to generate fresh water via condensation. You have a very hot element, you have a lot of water and steam, it'll condense down, and now you can collect fresh water off of these condensing units. So some incredible things you can do combining the natural resources that exist in the area, both the ocean and the geothermal. Another option we're looking at is using using a water heat exchanger for downtown industrial. And this is taking the natural element of the salt water that's sitting there in the bay, pumping that salt water in, and instead of running fresh water over the cooling towers on the tops of the buildings, when you wake up on a cold morning, you see all the steam and stuff coming off of the buildings. Well, that's hot water that's used to cool the building and for air conditioning purposes, also to cool computers and things of that order. But what happens is that water basically just evaporates off into space. That's 40% of the commercial uses of water in the county is simply for evaporation loss due to cooling towers. Well, instead of running the water of the cooling towers, let's use this cold water from salt water, use that as a heat exchanger to cool the water down, and just pump the water back into the bay. So we have some very local resource that we can take advantage of. Moving forward, we also have the idea of fog harvesting, thanks to another tip. Again, you'll see a list of acknowledgement of the people that provided tips and hints on things we should look up. Not only do we have the ability to harvest fog by using net technologies, okay? And this is net harvesting. You create these nets, the fog collects on the nets as the fog drifts into the nets. The water then forms droplets and then runs down into a cistern or some type of collection device. They use this in remote areas. But the other thing that we noticed was biomimicry. We remember a presentation we had not too long ago in FiRe about using biomimicry. Well, it just so happens that the Stenocara beetle has a shell that is designed to be able to collect dew out of the desert. And by collecting that moisture from the desert, that moisture runs down the shell of the beetle, and then it drinks that water. And so that provides the beetle how to live in the desert. So we see biomimicry as even being an interesting option. What if you happen to cover a building, for example, with using biomimicry and collecting water as the fog goes past the buildings in San Diego? We're about ready. So other additional ideas, we talked about salt-tolerant crops, solar energy for purifying gray water. There's a lot of solar energy here. We can use that to purify the gray water to get it into reclaimed water by treating it using that energy. And there's also symbiotic industries where we heat exchange. Industries that are actually generating heat and industry that actually require heat to produce their products. So there's some additional options there. So the summary is really get it right, get it going now. The next steps, we want to be able to hand this off to San Diego Water Authority for ongoing support, but we want to recognize that the San Diego Zoo has already offered to host a further discussion on this topic at the zoo for a design workshop on how to take this technology forward. And the members behind us would like to be able to have a follow-up progress report at the next FiRe.
Wow.
So one of the discussions we had is what would be the ideal thing that we could export? And one of the discussions came up was, well, you know, if San Diego County could export water, wouldn't that be great, right? Wouldn't that be an ultimate thing to do, is provide that to the rest of the county? But instead, we thought what would be more valuable, right? Instead of handing someone a fish, you teach them to fish. So what our production would be is to export the water model. What is the model that you can use such that San Diego could teach Los Angeles, for example, the neighbor to the north, a great model on how to actually provide water conservation methods. So we thought that would be a fine goal. So we want to acknowledge a number of the members that provided content for us, provided insight, tips, and good insightful thinking. John Prank from San Diego Zoo, David Morris from EcoVerdance, Roger Payne from Ocean Atlantis, John Bashirs, and Roger Foss from ZGF. Petra from Smato, Sophie from Xerox Park, Alan Smith and CY Lee from Vesta. That was a very great idea. Joe Sterling, who provided all of the drawings and insights for us, and we thank him so very much. And Bill Rose for our endless number of questions in handling all this, and of course Larry Smarr for Cal IT2, the HydroSeek application that we got to see there yesterday. That's something we're blending into the thinking. It's very exciting stuff.
Thank you.
But you know, we talk about future and review and talk about having fun. We just thought we'd take this from basically 3 years from now, and we'll note a few things from the Sacramento Bee, noting that, you know, San Diego Water Authority exports the most valuable resource, technology. Lake Mead, too much water, have to manage all that, a lot of pressure on that dam. The orcas are now returning to San Diego because the fish stocks and things of that order are returning due to the water in the canals and in the water features. San Diego announces a new water park, and of course, Governor Bill Rose nominates Mark Anderson for the Citizen of the Year award. So we thought that would be a nice way to wrap up.
All right, well, I think we're applauding several things here, including the marvelous, I don't think I've ever seen PowerPoint better done. Very, very crisp and to the point and well correlated with the slides, and actually giving Mark some hope as he's out there on his knees praying that we might come in on time. So marvelous job. And of course, thank you to all of you. Although I must chide you in one respect, Ty, and that is the blatant sucking up to the judge.
We get to credit the entire team with that. That was very much a collective.
Well, in the original TV show, the judge went away and then came back and actually, you know, had all the other fire inspectors, and there was dramatic music when it milked these guys, you know, going, did I really like that? And then they broad grin, dramatic and all that. But I'd like to open this up to the rest of the panel. I'd like to say one thing. You've mentioned right-of-ways, and I think that's a terribly important thing here. Right here in San Diego County, we have the Sunrise Power Grid that's been huge uproar over whether or not to build these new towers that would then go out to the Imperial Valley where the new solar farms are going. And I've always been a big fan of looking at rights-of-way because they're where the choke points are. That's how the gas company and the railroads became MCI and Sprint and changed their whole business plan because they had that key resource of rights-of-way. And to be able to use the rights-of-way of the existing aqueducts as a solar power farm where they would have to do less environmental impact reports, where they would get a 2-for, a 3-for, a win-win situation and simply carry the power along the aqueduct. I think this is one of these, among the ideas that you have. Some Xerox Park filtration and getting the gray water injected into people's backyards right away. I think these are some of the things that could have a quicker impact than some of the others. And I think that's very interesting. My mother-in-law just moved into a neighborhood where a full third of the front lawns are now pebble lawns with drip irrigation to specific, and they look great. And the culture moves. Once it reaches past 10%, the culture starts penetrating the community. But with the right-of-way, I'm just going to take my privilege here and talk about a thought I had some years ago, is that the battle of bringing internet into the home was a battle over rights-of-way. And for a while, the power companies were trying to bring internet over the power lines. And you can still do it on a small scale inside the house. Then it became a battle between the phone company and the cable. I was wondering, what else comes in and out of the house? And I was thinking water. But you can't string fiber optic through the incoming water because of all the valves. But then I thought, what about the outgoing? There are no valves. It's the classic U valve in your toilet is just water. So if you made extremely durable, and this is a business opportunity, if you made an extremely durable robot that would simply run through all the sewers, stapling fiber optic, you could deliver high bandwidth fiber optic to every toilet in America. And I think this could pay for the whole revision of the gray water, and it could pay for itself. So I'd like to open it up to the panel here. We actually have some time. Go for it. Talk about your ideas and which parts of this you're most excited about and you'd like to stay engaged in.
Yeah. So in fact, David, on the very last piece that you talked about, there's literally dozens and dozens and dozens of backup slides. The key here wasn't figuring out what to talk about, it was figuring out what to not talk about. But on the very idea you had, one of the regulatory things that we were talking about is actually some mandating that anytime you dig up the street for one thing, let's do the other things too. So anytime you're digging up to lay fiber, let's lay the purple pipes. Anytime you're digging up to lay the purple pipes, let's lay the fiber. I mean, it's a very incremental cost at the time that you do it. I must say, of everything that we talked about, for me personally, the one that I was singularly most excited about is the tying geothermal thermal to the desal at the coast. On one hand, it's the biggest bed, it's the most expensive, it's going to be the longest, it's going to be the longest out there. But it is the way that we could actually get a serious, at-scale amount of water from the ocean that's sitting right there, using a relatively infinite natural power supply that's sitting right there as well.
Yeah, I see this as a parallel to some of the cities where, Russian cities, where they have a central heating system that is at the power plant, and they take the final stage waste heat at the power plant and pipe steam throughout some cities in America actually used to be that way 100 years ago. And I see this as a desert inverse method of taking advantage of the cool ocean water that we have here, creating a central utility, and then having the companies simply pay their way to buy into this simply because they would save all that water and save all the expense. I think it's a great idea.
One of the things that framed our discussion and actually made the technology part more difficult was the half-cent problem. We talked about that. It flashed through one of the slides, but realized that at $1,700 an acre foot, which is sort of the marginal cost of water, of producing water through desal, that's a half-cent a gallon. So it really narrows the technologies that we can apply to this problem. It's a very difficult bar to get under.
Well, I think that socially is part of it. Once you get all the school kids, as my school kids did, coming home about 10 years ago, reciting the phrase, if it's yellow, let it mellow, if it's brown, flush it down. And then my son suggested, after reading a great Harry Harrison science fiction story, science fiction can inspire, he wanted to make his own gunpowder, and it's hard to get your hands on the, when I was a kid, the chemistry sets out everything, blow up everything, but it's hard to get the potassium nitrate. So he started going in back with some manure from Home Depot, and he's just peeing away and doing. And so he's not contributing to the stream there. He's actually doing a chemistry experiment. I don't know how relevant that is, but if you can get the next generation thinking of every flush as being something that hurts a little bit.
Some of the coolest things here are the big technological changes that you can imagine implementing, whether that's for how you would be using salt water to cool, or whether it's putting the solar panels over the canals. But that has a financial cost, and that means it has a political cost. Therefore, I think some of the local initiatives, the awareness, whether it's with children or getting people really engaged in optimizing the water efficiency of their houses, has a benefit not just in that you're saving water, but you're also creating a political body that will support these other initiatives.
Right. Excellent. Excellent. I saw you guys for a while there deliberating. One thing you didn't mention that's probably on one of your support slides is this plague of plastic water bottles. And I recently put these pure water filters on because I was tired of the Culligan. And they don't quite do as good a job as they ought to. And it would be really it would be cool if we could have just tap-oriented access to, and water bottles that you could refill with some confidence. We're going out there buying the stainless steel and all of that. I think that could help affect something that is actually a modern plague.
Well, I just add that I was, the first thing that I got excited about was the solar panel idea, because there's the issue of how you cover the canals and the cost of that, and then protection of that under the hot desert elements. But if you then had on top of the membrane that covered the canal, solar panels that would defer probably the wear and tear on that cover on the canals. And then we did a little jungle math, not any of us being solar engineers, but if you buy into Al Gore's idea that 100 miles square of solar generated power is enough to power most of North America, and if San Diego has roughly 2% of the population of the greater San Diego County area, that canal that we have, 100 feet wide and 200 plus miles long, is about 2% of the 100 miles square, which in theory says you'd power all of San Diego County on top of the canal.
Well, there's an added benefit, and that is that one of the biggest expenses of solar is the construction of the solar. That's right. Installation is actually over half of the cost of solar. And so if you can get a twofer, keep looking for those twofers. If you can cover the canal and create the infrastructure for carrying electricity from the desert to the city, and at the same time, while you're covering the canal, you simply mass-produce these arches.
Right.
And these arches simply
Drop them in place.
bolt them in place as you go along. It's these twofers that I think, this win-win situation that I think Mark and FiRe specializes in going for. The joyful notion that we get here at FiRe that capitalism should not be left as the image of some far-right rapacious thing. That it started with classic liberalism as a joyful way of getting positive-sum gains, of making a buck while making the world better. And that's what I hear from almost all of the panelists here. For instance, you were talking about desalinization using ocean gradients. Well, while you're doing it, you might as well stir that bottom mud and circulate it. Sorry, Roger. Any others, guys? Because we're going to throw things open to the audience if we don't. I think they've done a marvelous job. So you say there is an interest at the San Diego Zoo in holding a follow-up session?
That's correct. It was wonderful. John Prang came and during one of the sessions said, we would love to hold a meeting and host it at the San Diego Zoo. Particularly the biomimicry is a very relevant technology for the zoo, because here are creatures of the world providing us direction and guidance on how we can actually manage our water and be able to survive in the desert. And it's just a wonderful synergy to be working with the zoo on such an interesting project. So, we thought that was just amazing and excellent.
Well, once you have one sponsor and a romantic locale that's already paid for, it's relatively easy to get other sponsors. And once you've got these guys aboard and some of their colleagues, then it could turn into an important conference. And we've already got some important people committed to come back to this hell on earth. And it sounds like a wonderful thing. And of course, this would not be the CTO challenge for next year. I mean, we've gone through air, fire, water. I guess it has to have something to do with the Earth next year. But but I think a panel to report on what happened would be. I'm arrogating here. Does Mark think that sounds like a great idea? All right. So let's open this up to the wonderful participants out there in the audience.
Do we get feedback?
While
I'd love to hear what.
Yeah, we would.
just a second.
All right.
Hey, I've been on the TV show. These guys have got to be looking stern and as if they had
Skeptical.
as if they were hearing all of this for the first time. Let's hear first from some of the guys and people in the audience. Question there.
This beetle is a wonderful example, but there are several species that do it, and some of them actually stand on their head in a posture which makes them give a greater cross-section to the fog, which is coming in. That's just sort of an interesting thing to note.
Yeah, I've seen those in the nature shows.
Bob Anderson here. I heard your concerns about half a cent a gallon. In my room, there's some water for sale for $30 a gallon. So maybe you guys need to talk to the Dell to see something about water economics and water pricing, water marketing.
Anybody else? Don't be shy. There's somebody back there.
Yeah.
Great work, guys. You were talking about the smart meters for demand destruction, and talking about the, trying to get two levels of value out of some of these initiatives. And I'm just wondering what you think, or you knew that the smart meters do demand destruction for energy as well. So there's a real leverage there. But fabulous work. Thank you so much.
Great idea.
Thank you. Yeah,
Great idea.
That's a good one.
Yeah, I'm a big fan of the notion that if we can find some way to get down to the neighborhood level. For example, sensors, get the neighborhoods active with their own sensor webs that tie into the national sensor webs, that feed data to the national sensor webs and take data from, but also create their own view of what's going on in their neighborhoods. That
And
would
set
alert-
awards, awards and recognized neighborhoods. You know how you enter this is a crime prevention neighborhood and stuff like this. This is a water. This is a water correct or some other type of program.
And it can tie in with the community watch and pollution watch and sort of general trends toward a transparent society, but the point is that in this case, it's an empowered society, empowered neighborhoods. And then, within the neighborhoods, people trading notes about my gray water is being used now.
There really was an awful lot of discussion around shifting those social norms. I mean, how do we get communities to be the 2010 Green Community of the Year and have people competing because of all these great tools to be the low water user and yet winning the most beautiful lawn in San Diego County?
Well,
if we can get those social norms shifted, we are on our way.
And there was one other caveat to mention. Bill, you mentioned something I thought was very interesting, was that when you talked about the fire in the homes, and maybe you want to elaborate on that because it was your story, about the plants in the house and the fire.
Yeah, there have been a number of examples where people have used California native plants around their homes. 2007, this group, and some of you were part of that, looked at fire response in San Diego County. Well, there are stories out there of folks who've used California plants around their homes, who've actually just watered them occasionally, maybe a couple of times a month. Their homes were spared in those fires because the fire came up to those well-irrigated California plants, and it just stopped. I saw some pictures of a home that had about a 2,000 square foot wood deck right in the fire path, and it didn't get to it. And so those folks, their home was spared. So there are many opportunities for the use of native plants. I think one of the things that I was most encouraged by the panel is that we not only looked at the supply side, you looked at that, but you also looked at the demand side. It's really important. San Diego has a $171 billion economy that is based upon water. Imported water was brought into San Diego County in about 1947. And so our norm, if you will, is plentiful, cheap water. And that is changing dramatically and quickly. And so how we address it is important. How we look at what we do outdoors, what we do in our factories, what we do in our homes is a key to being able to reduce our demand. Also looking for additional supply, and I think this group has found maybe an opportunity in covering canals, but also the spin-off benefit of energy. While I know you never mix water and electricity, but in this business you do. Because I think the group found out that about roughly 20% of the energy consumed in California is consumed to move water from source to your table or to your tap. So those are really big numbers, lots of capital costs associated with that. Reduce the demand, reduce the amount of electricity produced, reduce the amount of pollution. It just keeps going and going and going. So.
I'd like to add one thing, and that is national security. It's not only the national economic security of being able to continue to run our farms and being able to continue to maintain our cities and the collapse that would result if we wound up short of water, but I've been pointing out in some other places that the security implications of just this tendency that we've gone on since 9/11 and even before that to emphasize being protected, to emphasize an infrastructure that's maintained entirely by professionals. And yes, we need this, but in the long run, we're going to be safer if we build a civilization that's robust. And the most robust civilization is one that can suffer damage to its infrastructure system and continue living. And the putting of solar cells, I think I said at the beginning session here, the putting of solar cells on our roofs is just the beginning, because you can't survive without electricity, you can't survive without water. And being able to dream in 20 years of having most of our homes be able to do some cisterning, some use of rainwater, some use of, for instance, if your neighborhood is only getting water 1 hour a day on a rationed basis, being able to store up enough water during that 1 hour a day that your fairly efficient home can make it, and that our civilization doesn't collapse and become a mass of refugees. And that's a sort of nightmare science fiction scenario because I'm paid for that. And now I'm going to make Mark extremely happy, and I think we're going to come in under the wire or only need a couple more extra minutes, and I'm going to pretend you're hearing really dramatic music and that you never heard from these guys before and they never attended any of the sessions, okay? Imagination. Gentlemen, what do you think? Bum, 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 bum.
My take on this is that the team has come up with some really good ideas that we need to follow up on. And there are solutions there that are going to need some additional study, but nonetheless, they're still really viable, and we should pursue them.
Terrific, and they even come from companies where they might be able to bring a little bit of their own funds into it.
Oh, shucks.
Hint, hint. Larry, what do you think?
Well, I think that the thing I see as the big opportunity in San Diego is that thing you said about how much is public land. There's so many of these things that, this is going to go on in nature, and it's all very well to say, well, we're going to switch this and this and this, but then those have complicated outcomes. So you need some rapid prototyping environments. We not only have our public land, like the parks and along the highways and so forth, we have our universities, and they're small cities. And so what we're doing at UCSD, and I think there's similar things at SDSU, is actually saying, okay, let's take our water system and our energy systems, go to the end of the rainbow when they're data intensive, and be able to actually follow every drop of water. I mean, in other words, we're making an energy internet in our smart grids. Why not a water internet that's actually tracking all of this? And then when you come in, that allows you to begin to put software, data analysis, and so forth, so that you can really know where the water is going. After all, the water is, water is water. The molecules don't disappear. You can follow that, but we don't have that data. We don't have that information on a space-time basis. And I think our campuses, for instance, the accelerant, we could be doing limited experiments on real irrigated spaces using that on our campuses. So I think there's a partnership possibility.
I think that's terrific, yes.
One last thought that I'd like to leave everybody with, and that is the time element here. And that is that we talked about getting it right. We have to do it now. And the reason we have to do it now was up on one of the early slides. It was that the Scripps researchers found a 50% chance that Lake Mead goes dry by 2020. If that happens, we have a world of hurt.
That's right.
And so if we do all these things right, we can maybe barely squeak by if we have an exogenous kind of shock to the system. So again, talking to robustness and the need for action.
Yeah, and it does become political too, because we're not going to be able to do anything about any of this until we end culture war. And sorry, Bill, get rid of the stupid left-right political axis and get back to remembering what we're about in this civilization, and that's being pragmatic problem solvers.
One thing we can take out of this too, I just want to take on Rob, is I think you're very right, Larry, in redefining the smart grid. It's not just power, it's water. And that's something I want to take back to Microsoft, because we are working on the smart grid. But let's do this right, because we realize the intertwined nature of energy and water. And as you were mentioning, Joe, as long as we're going to visit and put in technology, and Alan as well, let's go ahead and do the right thing and do the two first. Let's do water and energy at the same time, because it only makes sense.
Amen.
The right-of-ways, just keep following it along. I think we managed to do it in just 1 minute over. Is that all right, Mark? All right. Thank you all, and thank you, especially above all, thank you all for your imagination, for your practicality, and for having fun. Great.